This is a continuation of Chapter 6, further library classes, using library classes to implement some more advanced functionality. Concepts to be covered in this portion of the lecture is set and map. These are helpful in creating associations and avoiding duplicates. They have some very specific things attached to them, so it's important that you understand these and go from there. Writing your Java documentation is pretty straightforward what they give here, although it is a primer. There is substantially more information online, but you'll get the gist of it in this portion of the lecture. Hash set. Hash set is just another collection method that's in java.util. You use it the way this is listed here. It's very similar to what you see in ArrayList. You shouldn't see a whole lot of difference because they're designed to be very much alike. But they give you some advantages in the way the data is handled and in the efficiency. It tokenizes strings as tokenizing strings as an example. Public hash set string get input, gets an input from the user, they type it down, it moves everything to lowercase, and clears all the spaces at the beginning and the end. This is where it gets a character. And remember, it goes this way. So this returns a string, which gets trimmed, which returns a string, which is 2 lowercase. Why is that? Because string is not mutable. It is immutable. Now, input line, which the result is ultimately a string. It's going to go ahead and split it at the space. That's important for you to understand. It will show up later on in this class, so please take some time and look up split if you don't already know it and understand it. Hash set string words. So now what we're going to do is we create a hash set of strings, and then we're going to go ahead and for each word in the word array that was created here when we split, okay, we're going to go through it and we're going to stuff it into the hash set called words, and then we come out. That's an example of the use. At this point you're probably not thinking great or overly helpful, but more to come, and as always look at the documentation in the book. Maps are collections that contain pairs of objects parameterized with 2 types. They're called key-value pair. You supply the key and it retrieves the value. If you took a database class, then you should already be familiar with this concept. If you haven't, think of it as the key is unique, and when you supply that unique key, meaning you can't have duplicates, you get the value back. One example would be a contact list. So we have Charles Wen, Lisa Jones, William Smith. If I look them up by this, I will get their phone number. Here's an example. I'm putting that information into the array list. And then here I'm going to say get Lisa Jones, and it comes back with a string equal to the phone number. Okay? I do a get on this, it retrieves that. That's all it is. And here, if you look at the hash map, string, string. Now, what a lot of people do is they see this portion of the lecture and figure this is somewhat useless. Remember that this could be an entire object. So this could be an entire database, an entire row of data. And this could be just the unique key to get to that row of data. So this could be anything. It's an object. Okay, don't get lost in just that they use a string. Just to back up, so when you do this get, it gets the object portion that matches this. Excuse me. Hash map and responder. Private hash map, string, string. We already talked about that. The put, which version of this is, string response, get word. Based on this, it returns back that. Okay? If the response comes back as null, what does that mean? It means it didn't find anything. We talked about null in the last lecture, or last chapter. Please go through it if you're not familiar. List, map, and set. These are, again, just more things. You have an array list and a linked list, a hash set, and a tree set. Hash map is unrelated to hash set, which is a common misunderstanding, despite the similar names. The second reveals the organizational relatedness, in other words, how it handles the data. Okay? Collections and primitive types. The generic collection class can be used with all class types, but what about primitives? Now, if you remember, way back in my lectures, I talked about wrapper classes. Here's where we're going to go into them now. There are other classes that are created to handle this and be able to give you a little more capability. Suppose we want an array list of int, what would you do? Take a moment, think about it, and let me know if you have an answer. Down at the bottom of the screen are your answers. So int has a wrapper class called integer, float has one called float with a capital letter, char with a capital C character. Okay? So these have a bunch of things just like string, Kind of sort of has a map, but we'll skip that for now. But the wrappers exist for all primitives. Okay? So in here, if you're going to create a new integer, you can seed it with the value. This could be an integer here. You also could have just put the 18 in here. They're just showing you examples. To get it back out, int value gives you the integer version of the value if you wanted it to go back into a primitive. This is pretty rare, by the way. It's just shown for illustrative purposes. Autoboxing and unboxing. Autoboxing, putting it in, unboxing, getting it back out. In this case, if we knew that it was brand new and there was nothing else, then whatever I put in here would be the first one, and this is getting it back out. That's all they're talking about. Fancy words for a simple concept. Next, write your own class documentation. Should be the way library classes are. Other people should be able to use your class without reading the implementation. If you've written your classes right, they don't need to ever look at your source code. They should be able to take it and understand what the interface is through JavaDoc and run with it. Always code with the understanding and expectation that your code will be used globally by your organization or potentially get sold as open source to the world. This means you should always do your JavaDoc. And if your shop doesn't do JavaDoc, ask them why and tell them I said you should. Elements of documentation, but don't get yourself in trouble. Elements of documentation. Documentation for a class should include the class name, comment, describing the purpose, version number, authors, and so forth. This is all standard, and this is all in JavaDoc, and there's ways to do that. Documentation for each constructor and method should include, it includes a bunch of information. I can tell you from first-hand experience, writing this is a pain, and it's arduous, and when you've got 25 methods, you got to do this for each of the 25, you moan, you groan, and you hate it. But when you're a new developer coming in and you don't understand how things were written or why you would use this, that, or the other thing, you are thankful that it's written. So if anything, it's a pay-forward kind of thing. By doing it once right, it's there forever, and everybody gets the benefit from it. So start with a comment, end with a comment, @sign, this is waking it up. So for JavaDoc, and for JavaDoc. When JavaDoc runs, it scans for this, sees it, grabs this in, and sticks it into the area for the author and the version, and so on. For your methods, same thing, same start, @param, return, go from there. It works very well. It is absolutely worth doing it. You should do it across the board. Public versus private. So I alluded to this a long time ago in one of our lectures, and if you recall, I mentioned that there's a third type. We'll go through the third type at another point. But public versus private. Excuse me. Public elements are accessible to objects of other classes. So if something is defined as public, you'll be able to get to it from any other class. That violates the concepts of object-oriented development and design, so you should not do that as a rule. Fields should not be public. Private elements are accessible only to objects of the same class. Okay, so only things within that class can get to them. Only methods that are intended for other classes should be public. In other words, you should limit what you do and only use public sparingly. A lot of developers will change this because they want to make their life a little easier and they don't want to have to put the time and energy into creating their getters and setters or other similar things. Information hiding. This is a concept that's common in in Java and J2E, but it's an object-oriented principle. Data belonging to one object is hidden from all other objects. In other words, if you want my information, you have to come to me to get it, and I will get it for you and give it back to you in a format that you're ready to use. Just I may store it internally. So example, I might have an address and I keep the street number or the house number, the street name, the avenue, and the direction all as separate fields, but if someone wants to get your address, I'm going to return it back to them as one piece. They don't need to know how it's internally stored. Only I do. When you increase your data hiding level, you increase your independence. It's something we're going to talk about in our next lecture on Chapter 8, but this is a very good thing and it's something that you should absolutely do. Independence of modules is important, especially for large systems. If you don't do this, you will end up with spaghetti code and you will have pain later on. It's always better to do it up front. The next topic, a lot of independent small topics, is code completion. When you work on your editor and you're trying to do something, BlueJ supports lookup of methods. This is pretty common in most IDEs. So once you type a class as an example, you do dot, control space, it'll bring up a list of everything that's in that class that you have access to. Use return once you've got it on your screen to select the method. So here's an example. They typed myCanvas dot. MyCanvas is of type canvas, I believe. So they did a dot, and up comes all my methods, as well as variables you can get to. You scroll up and down, you hit enter, it puts this in, and it helps you fill in the code. So as a result, it's much easier to code, makes your life a lot simpler, and it's a nice thing to have, especially as a new developer. Once you've been coding for a while, you don't rely on it as much, but when you're not quite sure about that one class and that one method, and was it get something, I don't remember, control space. To review, Java is an extensive class library. As a good programmer, you should be familiar with the big libraries like .util. The documentation tells us what we need if you're using Java properly. If you're coding correctly, the implementation is hidden from other classes, and that if they would use a getter or setter to do things or interact with you, or mutators. We document our classes so that the interface can be read on its own. In other words, if you're doing this well, nobody needs to look at your source code. Okay? Next topic, we're almost done. Class variables. Class variables are shared between all instances of that class. In fact, it belongs to the class and exists independent of any instance. All right, so what they're talking about is if you have a class variable and you use the word static, all right, I call them static variables, I seldom call them class variables. But if you have a static variable, it gets created once at the class level. So all instances of that, or all instances of that object, the object is what's in memory, will have the same value at the same time, and it operates once in memory. You typically do that for things that are constants, and we're going to talk more about that in a little bit. But public static variables are accessed via the class name. So in this case, if I had a class name thermometer with boiling point, I would put this in just like that, and that's all you would have to do. In fact, you don't even have to instantiate it. Looking at this object diagram, this is a class. Gravity is static. So gravity exists in all three of these instances of ball, or bouncing ball, which is what we talked about. Okay? Very common, very helpful, but be careful when you use static, because people will often forget that, and then they're modifying a value in one part of your code that changes it in another. A variable once set can have its value fixed, and that's through the final keyword. So if you create something final, whatever initial value is created, it's created one time and never can be changed. That's very common for a constant. This is where you make it all capital letters, and that's just a standard. There's no requirement to do that, but this is a very good idea. If you have multiple words, size of shoe would be size underscore of underscore shoe, and that's how you do it. Now think about it. If you combine static and final together, why would you want to have multiple copies of size if the value can never change? So if you make it static and final, then size is created only one time and exists forever. The way it would look, private static final int gravity. If you take this off, you made it public, that also is considered reasonably acceptable. Here's an example down here. Okay? Notice the underscore that I talked about a little bit ago. We can take it from there. A static method belongs to its class rather than instances. So this is a pretty common thing. Public static void main is one example. Be careful when you do things like that. You do run into certain surprises, and there's certain coding issues that you may encounter. Use it sparingly, but there is definite value in doing it. Static methods are invoked by their class name, just like the variables. Limitation of class methods. A static method exists independent of any instance. We talked about that before. Static is static is static. Method or variable doesn't matter. They cannot access instance fields within their class. Why? Because they're at the class level, not at the object level. Instances are copies of the object. Remember that. And they cannot call instant methods. Why? Because they're not part of an instance. They're part of the class. And that is one of the largest debugging headaches that you'll have if you make that mistake, because you won't necessarily remember it. Review. Class variables belong to their class. We talked about it versus its instance. Remember, a class variable is when you create it as static. Class methods belong to their class rather than its instance. Class variables are used to share data among instances, and class methods are prohibited from accessing instance variables and methods. Okay? The values of final variables are fixed, and others are set once. They must be assigned at declaration or in the constructor. That's very important. Final and static are unrelated concepts, but they're often used together. It's rare that I see them separate. I'm trying to think of an example right now, and I can't come up with one. The rest of this lecture is further advanced material. There's nothing huge in here. There's polymorphic collection types, and they're just talking about some of the capabilities of this. It's not going to appear in the test or in our lectures, so I'm just going to go ahead and page through it. With that, that's the end of the Chapter 6 lecture. As always, I hope you got something beneficial out of this. If you have questions, as always, please email me. Thank you.